Hey, thanks for stopping by. If you're new to the channel, my name is Triston. I do HackerRank challenges. If you like that kind of stuff, go ahead and hit the subscribe button. I really appreciate it. And let's get to the challenge. Alright, so this one's called Apple and Orange. So it looks like we're going to be, without even reading, just looking at the diagram, it looks like we're just going to be seeing how many apples fall within a range and how many oranges fall within a range. I feel like this is going to be pretty simple. Sam's house has an apple tree and an orange tree that yield an abundance of fruit, and the diagram below, the red region denotes his house, where S is the start point and T is the end point. The apple tree is to the left of his house, and the orange tree is to the right. You can assume the trees are located on a single point, where the apple tree is at point A and the orange tree is at point B. When a fruit falls from its tree, it lands d units of distance from its tree of origin along the x-axis. A negative value of d means the fruit fell d units to the tree's left, and a positive value of d means it falls d units to the tree's right. Given the value of d for m apples and n oranges, determine how many apples and oranges will fall on Sam's house, i.e., in the inclusive range St. For example, Sam's house is between S equals 7 and T equals 10. The apple tree is located at A equals 4 and the oranges at B equals 12. There are M equals 3 apples and N equals 3 oranges. Apples are thrown apples. E equals 2, 3, negative 4 units distance from A. And oranges equal 3, negative 2, negative 4 units distance, adding each apple distance to the position of the tree. If I can read, they land at 4 plus 2, 4 plus 3, 4 plus negative 4, and 6, 7, 0. Oranges land. So if I'm looking at A, I can dismiss all negative values. I only focus on the positive values, and if I'm looking at tree B, I dismiss all positive values, and I only look at the negative values. We would just check the I would say that we would check the distance S to A. We would check the distance there, and then we check if the distance D is within the range of S and T. Complete the count apples and oranges function in the editor below. It should print the number of apples and oranges that land on Sam's house, each on a separate line. Count apples and oranges as the following parameters: S, integer starting point of Sam's house location; T, integer ending location of Sam's house location; A, integer location of the apple tree; B, location of the orange tree. The first line contains two separated integers denoting the respective values of S and T. The second line contains two space-separated integers denoting the respective values of A and B. So S and T is the house, A and B are the trees, and then apples and oranges are arrays of the apples and oranges. Alright, so let's start coding this up. Base case. What is our base case? Loop apples. We're going to loop oranges. We're going to do some logic within the loop. For apples, we're going to check apples, all negative values. Check for pause, vals only. And then we're going to check distance to house, and here check for neg vals only, and check dist from house. This could probably be its own little function, but who cares. And then we're going to have a count. So dist in range count plus plus, and dist in range count plus plus. This should be count A plus plus, and this should be count B plus plus. What is distance from house? This would be A plus M, and check distance from house, B plus N. And I think that's, and then at the end, then we would return count. Actually, it wants us to print, so we would do count dot for each count console log count, like that. Let's write the code. So say let count equal, and obviously we do a raise around here. Let count equals 0, 0. Apples dot for each. We like the for each around here. Apples dot for each. Check for position. We're going to say if apple is less than 1. Yeah, because I said it'll always be equal. Okay, so if it's less than 1, then return. No. Yeah. Otherwise, check the distance from the house. No, if apple plus A is greater than S, and apple, that's going to be way too long-winded. So we're going to create a variable. We're going to say let dist equal apple plus A. If dist is greater than S and dist is greater than, or is less than T, and honestly I think it could be less than or equal than. It's greater than or equal than T, greater than or equal to S, and dist is less than or equal to T, then we would count plus equals, and this will actually be count O plus equals 1. Alright, that's pretty much all of that. And then the same thing for this one, loop oranges. We say oranges dot for each orange, check for neg vals, if orange is greater than, yeah. If orange is greater than -1, then return. And check distance. Check distance would be the same thing, pretty much let dist equal orange. What is that? Orange plus B. And now if the distance is in the range, geez Louise, what am I doing? Alright, if the distance is range, if dist is less than or equal to T, oh no, it's pretty much, it's the same. So if dist is greater than or equal to S and dist is less than or equal to T, then count 1 plus equals 1, and then we output. So we would do count dot for each count console dot log count. You can clean this up by making a little function for that. So I think that's it. Let's run the code and see what happens. I don't know why I said wrong answer down there. I haven't ran the code. Hey, that's 1-1 though. That's, of course, I mean, that's so simple. Let's submit the code and see what happens. Hey, we passed all of them. Nice. Honestly, I wasn't too sure that I was going to get that on the first try. I thought that, you know, maybe I would have at least missed one. Because, I mean, I've never seen these before. I don't know what I'm supposed to be doing. Just kind of reading them and going on the fly. Let me delete all this, kind of clean this up a little bit. All my notes. Loop apples, count. Alright. And that is the... yeah, so that completes this video. Hope you guys enjoyed it. If you did, hit the like button, hit the subscribe button. Leave a comment down below, you know, if there's anything you want to see, if there's anything I can improve on. If I kind of changed my camera over a little bit, you know, I was hoping this may be a little nicer to look at. yeah, I'll see you in the next one. Bye.